Okay, this is the review for the next test. We have our systems, 3x3 systems, word problems, that type of stuff on here. We are going to do everything with the calculator. No need to mess with doing it by hand. Plug in the calculator and go. Let's start off by doing that. I'm just going to go with number 3 right here, and that's it. All these are 2x2 systems except for number 4. Number 4 is a 3x3 system. It is done the same way, except you have 3 variables to worry about, or in this case 4 columns. Alright, first things first, we need to make sure they're in the same order. This one has m, n, then a constant after the equal sign. This one is not written like that, so we're going to have to move this one over. So I'm going to take this, and since it's on the wrong side, I'm going to go ahead and I'm going to move it over here. It needs to go behind the n, and when I change it over, it's going to become negative. So let's rewrite it. Negative 7m minus 8n equals 9. That's the top one that we don't change. And then this bottom one, I'm sorry, this goes over in front. So that's going to be negative 4m, because I have to change the sign when it goes across the equal sign. My plus 9n, I need a sign there. I can't forget to put a sign. If you don't put a sign, it means multiplying, and we're definitely not multiplying. Then I'm going to have my equal sign, and this is on the right side of the equal sign, so it stays as is, as negative 22. At this point, you could either go straight to the calculator, or you can write the augmented matrix. Since this asks us to actually write the augmented matrix, we're going to write the augmented matrix before putting in the calculator and getting our solution. Our augmented matrix is this thing. I simply take my coefficients. If it is not there, we put a 0. If it is just a letter, we put a 1. So we have negative 7, negative 8, 9. Then we have negative 4, 9, negative 22. That's it. That's our augmented matrix. Sometimes we can put a line here to denote the equal sign. That's fine. Alright, calculator. First thing with the calculator, please, 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 clear your calculator. Second, plus 712, enter. And it is cleared. We are going to use the matrix key. If you look at the matrix, it's above this little symbol right here, matrix in blue. So to get there, we press the blue key and then matrix. When I go up to matrix, there are 3 different headings under here. There are the names, simply the names of our matrix. Math, that's the math we can do with our matrices. And then edits, where we actually put stuff into our matrix to work with it. We are going to use all of these, and we're going to use this order. We're going to put them in edit, then we're going to use math, and then we're going to use a name to specify which one we're going to do math on. So we do edit, math, then names. We go backwards through all 3 of these. If you have not used all 3 of these, you're wrong. So let's go over to edit. We're just going to put an A. Get in the habit, just put A. If you put A, B, C, and have different ones, you could get confused which is which. So we go to A. This is a 2x3 system. There are 2 equations, and that means 2 rows, and there are 1, 2, 3 columns. So that's 2x3. And this will set up as is. You see where it has this type of look, but instead of actual numbers, we just have zeros in there. So 2 enter, 3 enter gets us these. And now put these in left to right, then the next row, one row after row. So negative 7, enter, negative 8, enter, 9, enter. Next row, negative 4, enter, 9, enter, negative 22, enter. That's it. After this, do not try to start doing work. Once you've plugged all that in and press enter, quit. If you don't quit, what happens is you start doing steps and it tries to put this in this. What this is showing is you're still trying to enter stuff where this negative 22 is. So if you start trying to do math now, what's going to happen is you're going to try to put a matrix into this matrix, and it's going to confuse the calculator and give you an error. So when you're done putting them in and have pressed enter, second quit. Now we go back to matrix for the second time. We need to do math. By the way, there's that 2 by 3 matrix we put in there. Go over to math, and we're going to go all the way down. We're going to go simply to RREF. REF is above it. REF above it is row echelon form. This is reduced row echelon form. It gets you straight to the answer. So RREF, enter. Now we go back to the third time. Second matrix. We put that matrix in there. A. RREF, A. Enter. And there's my solution. What this represents is I have X, no Y, and then X is equal to 1. There would be an equal sign there. Then there's no X, but there's 1 Y, so Y would equal -2. So my first variable is equal to 1, my second variable is equal to -2. In this case, we have M and N. Which was first? This column is my M's. So my M is equal to 1. My second column is N, so N is equal to -2. My solution, I write M is equal to 1 and N is equal to -2. That's my solution. You could also leave it as 1, -2 if it was X and Y, but I don't really know which one would come first, so just specify which is which. 3 by 3 again is done the exact same way. X's, Y's, Z's, and then constants. It would be a 3 by 4 system, but do check this is not in the right form. You have to manipulate the right one there. Other ones of these are pretty straightforward and simple. Let's do a 3 by 3 system with word problem, and that will be the only word problem I do, because the word problem is done the same way. You just transfer whatever equations you get to a system, to an augmented matrix, and you get the solution. So let's work on that for Big Ben Sports Shop question right here. So on Monday, it has balls, bats, and bases. We have to come up with a key for that. So let's call it balls X, bats Y, and bases Z. There's 3 of them. So I know I'm going to need 3 different equations. Let's go ahead and write that out. So if I have 10 balls, that is 10X plus 3Y, which are my bats, plus 2 bases, which is Z, is equal to $198. My next one, so that was Monday. My next one on Tuesday, I have 4 balls plus 8 bats plus 2 bases is equal to $156. Then the last day, on Wednesday, we have 2 balls plus 3 bats and 1 base, all for $67.20. I am not going to write the augmented matrix. I'm going to go straight from there into the calculator. It's a little bit harder this way, but a little bit less writing as well. So we're going to go in here, and we're going to go back to the matrix. We're still going to go use all 3 matrices, but we have to do something a little bit different because we already have data in there. So what I would do is I would go second matrix, over to edit, just like we would do, go back to A. Now, if it's another 2 by 3 matrix, I can just go over and start filling in the values. But since it is a 3 by 4 now, I have to go change this. 3 enter, 4 enter. And you see all it does is expand with new rows and it puts in zeros. I go through 10 enter, 3 enter, 2 enter, 198 enter, and I'm back to the next row. Check to make sure it goes back to the next row so you're putting them in the right place. 4 enter, that is 8, right? Yeah. 8 enter, 2 enter, 156 enter. Next row, good. 2 enter, 3 enter, 1 enter, since there's 1 Z, and then this is 67.2. I'm done. I press enter. I need to press enter, and then I quit. I go back to matrix the second time. I go to math. I want to do the RREF, and then I'm going to put that matrix back in there. Second, oh, not math. Go back in your second matrix, and I'm going to put that same A1 in there. Even though it looks the same, it's a different matrix this time. There it is. So what does all this mean? Well, make sure I can see all this. Okay. This is my X. That means my balls cost $16. It's a very expensive baseball. Then my bats, which is my Y, which is the second column, cost $10.80. And the last one, my bases cost $2.80. Ooh, see all that? That's all I need to do. First column is my X's, which was the balls. Second column is the Y's, which is the bats. And Z is the bases, which is the last one. All of these word problems are done the exact same way. You just have to get to here, plug in the calculator, get the answer, and make sure they match up to what your keys are, what your numbers are. Next section we're going to do is just simply write the augmented matrix. We've already done this, so let's pick one of these to do. First thing I'm going to tell you, they need to be in order. For this one, let's just do number 10. You can do 9 on your own. This is R, this is S, this is T, and there's my constant or my numbers here. RST constant, RS, oh, my T's in the wrong spot. Where does my T go? My T goes right here at the end. And this one's in the right spot. So this negative T goes over here and becomes a positive T. I would highly suggest rewriting this on your own. So let's write the matrix. So the only one that needed change up RST down here is this one. This is the only one that needs a little change. So I simply write my coefficients. 4, 4, 1, since there is no number, that is 1, and then 24. 2, S is negative 4, and T is positive 1, because when it goes over again it is positive. And that leaves us nothing over here, and if that 0 is not, the equal is not supposed to be there. Then we have 5, negative 4 again, and we have negative 5, and we have 12. So again, this is my R, S, T, and my number there. And again, you can put that line there if you really want to. Going the other direction, which is 11 and 12, is even easier because they're already guaranteed to be in the right order because the matrix has to be in order. So let's do 12 just to keep it equal to the other side. That's my X, that's my Y, that's my Z, and this is my number after the equal sign. That line represents the equal sign. So I have X minus 6Y plus 4Z is equal to negative 12. Then I have X on the next row plus Y minus 4Z is equal to 12. Then I have 2X plus 2Y plus 5Z is equal to negative 15. There is my system. That's all we have to do. Write it in RREF. Guess what? That is what we did here, and that is what we did here. So let's do. Well, I'm not going to do that one for y'all. Just know, instead of writing my solution like this in the word problem, I tell you what each of them is equal to. If I give you a problem, I tell you what the variables are. If I want the solution in row echelon form, oh, that looks bad. It's going to look like this: 1, 0, 0, and then a number. I don't know what that number is. Then it's going to be 0, 1, 0, and a number. And this is going to be 0, 0, 1, and a number. Those are my solutions. X is equal to this, Y is equal to this, Z is equal to this. That's what I'm looking for in here. You plug in your calculator, you figure out what these numbers are. What is not a translation of the equation of the system? Okay. So 14. That's interesting. Which of the following is not a translation of one of the equations of the system? Okay. So let's look at this. If we have, let's make this a system of equations first. So we have x plus y plus z is equal to 700. Then this is negative y plus, negative 2y plus z is equal to 0. And then I have x minus y is equal to 100. Let's look at these. Let's kind of move those around. Well, we'll test them. And remember, these are my 6th graders, 7th graders, and my 8th graders? Yes, 6th, 7th, and 8th. The population of Lincoln Middle School is 700 students. Does this support it? My 6th graders plus my 7th graders plus my 8th graders, 700. Yes, that looks good. Not, so we're looking for not right. B, we're trying to choose, there are twice as many 8th graders as 7th graders. 8th graders are my z's. This one has z by itself, so let's go ahead and solve this. This is z is equal to, if we move that to the other side, that is 2y. What's going on here?